Okay, Chuck, I thought I'd do this little video for you, as I could see you were struggling with the ER32 collet system. What you're looking at here is a Cat 40 collet system for a Haas mill, which I've just purchased. Now, this is how it basically works. Just pull this out of here. In here, you can see, it focuses on it, the hole is not central. If I can get right over the top of it, there it is. You can see it's not central. And it's got an offset for a specific reason, which I'll come to shortly. But first of all, a little bit more about the system. So, what do we have here? We've got your cap. We've got a collet, which happens to be a 1/4 inch one. We've got a 1/4 inch solid carbide end mill. You've got the collet body itself. There's a stop. And there's a ball bearing, which doesn't come with a collet, but you'll need in this particular case. And you've got to think about a pull stud. Now, you won't probably need a pull stud on your machine because you haven't got an automatic tool changer, but if you had an automatic tool changer, you need a pull stud. So, this is how the system basically works. This is a left-hand thread, and it goes in here. If I can get it in, and you can screw it right down. This is your backstop. Now, because we've got a 1/4 inch end mill, which is actually smaller than the hole in there, which you can't see very well, there is actually a hole through there. I can show it. There it is. There's a hole right through there. And the 1/4 inch end mill drop right through that. So to get round that, we just put a ball bearing in there, or something to just block the hole up. Now, this system here, when you do this, you have to push this collet in here, so it's virtually flush with the top face. This one's not quite flush, but it is fully home and concentric. And then you assemble this in your collet body, like so. You do not put it together with the end mill in it. You would then put the end mill in there. It should fall down to its stop there. And you will screw the screw in here, which is a left-hand thread, until the tool is pretty well where you want it. So like that. If you wish to use a tool, a pull stud, it goes in here. I'm not going to put it in there for now, but that's where it goes, and you tighten that up, snug that up. Now, we move over here. I haven't unfortunately got a collet wrench here. You have a collet wrench, but this is a collet holder for a Cat 40 tool holder, and it sits in there like so. And then you would do this up until it's tight on your tool. And I haven't really got a proper wrench here to do that, but that's how you use this system. And you can get really tight on these, and you need to get tight on these because you don't want your milling cutter to spin. And so I've put bits of pipe on them before to get them really tight, to stop them spinning with big milling cutters. This little one probably won't be a problem with a carbide cutter. So I thought I'd do this little video for you just to show you how this works. Now, What is the eccentric offset, it's not really eccentric, the offset machining in there for? Well, what it's for is when this is done up tight, it actually extracts the collet out of the holder, and that's what it's for. It's to enable the collet to be pulled out. It sometimes will actually hold the collet in there, but be careful, they don't always do that, and the collet will fall out, and they're hard and they can fall on the floor, and they'll break. These carbide cutters are also very delicate and will break easily, so all has to be handled with care. So there you can see the actual ball down in there, but you could use anything really, a small plate of steel or anything, but I just happen to have a ball bearing which does a neat job. Anyway, I thought you'd like that little explanation of the ER32 collet system and a Cat 40 tool holder. The R8 system you have is pretty well the same. It may not have the backstop in there, but I'm sure it's got something in there. They usually do have. Anyway, best of luck.